All right, welcome to section 2.2 part 3. This is kind of like a bonus section here. This is actually pretty cool that we're going to learn today how you're going to learn one of the crazy things that these calculators will do for you. All right, so we're still learning about polynomial functions. What we're going to learn today is how to model real life. So everyone asks me, how would I ever use this? You may not personally, but if you do have a job that talks about statistics or numbers or there are jobs out there that would use this kind of information to model data. Okay, so we're going to do one example. All right, it says you can use your graphing calculator to model data that exhibit linear, quadratic, cubic, and quartic behavior by examining the number of turning points suggested by a scatter plot of the data. So what we're going to do is we're going to create a scatter plot, and then we're going to figure out if it's linear, quadratic, cubic, or quartic. And then we're going to come up with the equation where the calculator is going to come up with the equation for us. Okay, and then there's one important thing here, and we'll talk about this later, but this R value. And after we're done with this first example, I'll talk to you about what this R value means. All right, so example 1. All right, so you really have no idea how to do this. I'm going to teach you how to do this from the ground up. It says example 1, population. The median age, so that's like the middle age. That's like what the average middle is. Okay. The median age of the United States population by year predicted through 2080 is shown. So for instance, in the year 2020, the average middle age of a typical United States citizen is 40.2 years old. Okay, that's what this information is telling us. Okay, so, and it goes from 1900 to 2080. Okay, so in the year 1900, the average middle age of a person was 22.9. Okay, pretty young. All right, so it says write a polynomial function to model the data. Let L1 be the number of years since 1900. Okay, so if we want to think about this, so your L1 is the year since 1900. So this one will be year 0. 1930 would be 30. 1960 would be 60 years past 1900. 1990 would be 90. And then 120, so unless it's going up by 30. And then 150, and then 2080 would be 180. Okay, so our X values are years since 1900. So if 1900 is the starting point, 0 years. 1930 would be 30, and so on. Okay, and then the median age is going to be our Y. All right, so how do we put this in on the calculator? Okay, so I'm going to go to my calculator, and we are going to go to where it says stat. This is where you can type in statistics. So I'm going to hit enter on stat. And then I'm going to hit enter on edit because I want to edit my list. So this is just like an Excel spreadsheet. We have list 1, list 2, list 3. We always want to put the information in L1 and L2. Okay, so we're going to do our X values in L1. So 0, enter, 30, enter, 60, enter, and then the next one was 90. So I didn't hit enter. And then 90, and then 120. Okay, notice, and then we had 150 and 180. Oops, so 150, enter, 180, enter. Okay, so there's our list 1. Now in list 2, let me see if this will fix here. All right, so that's better. And then list 2, we're going to put our median age. We're going to put our Y, and you just hit to the right, and it'll go to L2. So 22.9, enter, 26.5. So we're basically just inputting some statistics, 29.5. And then we had 33.0, or just 33. And then we had 40.2, 40.2, enter. And then we had, oops, I could do this, 42.7. And then we had 43.9, enter. All right, so now what we want to do is we want to learn how to get this information onto a scatter plot. All right, so if we notice here, our X column goes from 0 to 180. All right, so I want to change my window and I want to go from 0 to 180. Let's go to 200. And then we can go by, I don't know, we'll go by 20s because we don't really need to go by 1s. And then our Y min, okay, notice, what was our Y? It went from 22.9 all the way up to like 43. Okay, So I'm going to start at 0. Actually, we're starting at 22. I'll start at 10, and I'll go to 50, and we'll go by 5s. Let's say we'll go by 5s. All right. Now, when I hit graph, can't really see anything. So I need to make sure my window, see, the window is good, but the plot's not started. So if we go to y equals, you see up at this top here, we have plot 1, plot 2, plot 3. You actually have to go up there and highlight plot, and then that will graph our scatter plot. Okay, so there's the points that we labeled. All right, now I might want to go to, I'm going to start at -5 so I can see that first point. All right, so now we can see our first point. Okay, so notice this is pretty darn near what a line would look like. Okay, if I could draw a straight line, if this little point was down a little bit further, what we want to do is we want to figure out what the line of best fit is. I want an average line, okay, that can give us some information about this. Okay, so once you figure out what it looks like, the shape, then you can figure out what type of equation that you want. Okay, I believe that this looks like a line. Okay, so I'm going to go to stat again, and if you go to calculate, okay, and you go down, you'll see a bunch of things that say regression. REG means regression. So we have linear regression, quadratic, that's parabola, cubic would be sideways S, quartic is either an M or a W. Okay, so we said that this one looks like a line, so we're going to do linear regression. We're going to enter. Okay, once it's on that screen, you're going to enter again, and it tells you a bunch of information. It says y equals ax plus b, like mx plus b. It tells you what your a value is. It tells you what your b value is, so it gives you the equation. Okay, and then this r value, this is also now a very important number. This r value here is important. The closer it is to 1, the better your line of best fit is. So you want to make sure this r value is pretty close to 1. 0.98, 0.99, because it rounds, is really, really close to 1. So we know that this indeed is a linear regression. Okay, so our a value is 0.13. Okay, so I'm going to go down back to my problem. All right. Oops. Okay, so y equals 0.13x. Remember, x to the first is line. And then what was our b value? B value is 22.7. Okay, so we're going to go back. So plus 22.7. Okay, so there is our function for this data. It's a line, and there's your equation. Okay, so now what we're going to do is we're going to go back to our calculator. We're going to go back to y equals now. We're going to plot this in so we can see what it looks like on our scatter plot. So 0.13x plus 22.7. And if you hit graph now, there it is. It puts it in. And you can see that's a pretty good average of all those dots. It kind of goes right through the middle. It touches some of them. It gets pretty close. Okay, so that's what you kind of want to do for these. Once you have your equation, you want to plot it in and see if it looks right. If it doesn't look right, then you might need to change it to a different shape. Okay, so that's part A. Okay, part B now, so this is the same information. It says estimate the median age of the population in 2005. Okay, so we can do this one of two ways. We can go to the table, and so the years for 2005, okay, how many years is 2005 past 1990? So that would be 105 years. And remember, these are your x values. Okay, so we could go to our table. All right, so we could go to our table, second graph, and we want to go to x equals 105. So I need to change my table, and I'm going to go to 105. And I'm going to go by ones. So there. Okay, so at 105, at 105 years, what is the average median age? 36.35. So this equals 36.35 years old. Oops. Now, how else could we do that? Okay, the calculator will also do values for you. So if you hit second trace and you go to value and we want x equals 105 and you hit enter, there it is. It puts it right on the line. And notice it's literally right on top of the line. So it's at 105 years past 1900, the median age is 36.35. So this is what statisticians use. They use lines of best fit, and then they can average out depending on where your point falls and what it will be. So we could figure out, okay, let's do 300. Oops. So second trace value 300. So we want to know what the median age will be 300 years from 1900. So 2000, 2100. So this would be your 2200. Let's figure out what the median age would be. Oops. And why won't it work? Because it's not in our viewing window. If it's not in your viewing window, it won't recognize it. So that's my fault. Okay. Now let's do the last question here. It says, according to your model, in what year did the median age of the population reach 30? So now we want to know when our y value is 30. And if we look up here, it goes from 29.5 to 33. So we know 30 is going to be in between these 2 years somewhere. Okay, so we want to know when our y value in our table is equal to 30. So if we go back to our calculator, and notice here, it's going to be between 60 and 90. Okay, so remember, this is 60 years past 1900, this is 90. So it's going to be somewhere between 60 and 90. So I'm going to set my table, let's set it at 65. Okay, so that'll get us pretty close. All right, so 65. Now, notice, y is equal to 31.15. We want 30, so I need to actually go up. All right, so we want to get as close to 30 as possible. All right, so the line of best fit says, now, just because the chart says it's going to fall between these two, this information is for the line of best fit. We want to go based on that information. So this is more accurate than our table. So if we notice, it goes from 29.98 to 30.11. So it's somewhere between 56 and 57 years. Okay, so for your answer on your paper, you could put between 56 and 57 years old. Oops, not years old, but just between 56 and 57 years past 1900. Okay, so this one, if it's 56, it would be 1956, and if it's 57, it's 1957. We could get a little more accurate here. We could change our table to go by, I don't know, 0.5, and we can see if we can get closer to 30. And there we go, 56.5 is 30.045, so we're even closer. You could even go by 0.25s and get even closer. But the line of best fit is what will help us do this, okay? So I have one more example here. If you want to try this on your own, please do, but we're going to do it tomorrow in class. Have a good night, and I'll see you tomorrow.